All right, friends. So I'm going to try and be somewhat quick on this so that if you're catching up, you can do it as fast as possible. Take a second to pause and think about these do now questions. Okay, so before you actually do anything, I want to remind you that this is the worksheet that is going for today. So the do now, these definitions and your own definitions, and two things you think about the practice questions, all of this is going into the note taking learning goal. It's the final time I'm assessing it. The thing on the bottom, if you scroll all the way down to the exit ticket, that is a different learning goal. That won't be the final assessment of the 1.4 learning goal, but that will be an assessment of it. Yeah, okay, let's go back to these. So again, pause. You've got a spot to write these. Think about it. Okay, so highest orbital energy. Low orbitals are low energy. So lowest, this one's medium, this one's highest energy. Pink slash purple, highest energy. How many orbitals contain electrons in this atom? Two different orbitals. The black orbital has got electrons in it. The green orbital has electrons in it. How many electrons are in the outer orbital? So some of you might have said zero because you would say pink, that's an outer orbital. Some of you may have said four because the green is not the innermost orbital, right? It's outside of the black one. So this has four different electrons in it. Both are correct because outer orbital is kind of vague. Why is the letter C in the middle of this atom? C represents carbon. It's a shortening of the full word for carbon. It's a chemical symbol for carbon. It means that there's six protons on the inside. Last class, we made some corrections to the 1.3 learning goal. If you want me to grade it again, you need to click submit. We talked about how to take good selfies with warm lighting and cool lighting, and we introduced the periodic table of elements. This class, I'm going to talk about my family. You're going to talk about your family. Talking about chemical families on the periodic table. What does this have to do with electrons? We're also going to answer that question. So here, there's a little exercise. We're talking about my matriarchs. My mom's side of the family. Here's my mom. Here's my grandmom. Here's my great grandmom. Here's my great great grandmom. Here's my great 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 grandmom. Got Kelly Carey, Joanne Stanfill, Irene Patton, Nora Borders, and Alice Young. What a great set of women. Love them to death. I think about some common traits in my family. So, like, families got common traits. So, it's things that people do and similar. In my family, we're compassionate listeners. On my mom's side of the family, we're all white. We talk way too loud and way too much. We ask good questions. And maybe think about, well, let's go back to this picture and maybe think about what do you think is another common trait? Think about that. Here's a question: what does family mean to you? So when I ask you these questions, if you weren't taking part of class, then you weren't able to do the pair deck. What you're going to do instead of doing the pair deck is you will be able to answer these questions below the do now. What I would do is I would create some space after this number 4 right here. And if I'm asking you to answer a question, I need to see you take some notes on answering these questions. So if I say take this on your study sheet or on your worksheet for the day, then take it on your worksheet for the day. If you're making up the class, if you were there and you just want to rewatch it again, don't worry about filling it out again. But if you were not here, if you were totally absent, you got to fill these out. Okay. So answer this question: what does family mean to you? Mom and dad, tios y primos, your best friend, is it a stepdad? Is it a abuelita? Take a second to pause. Think about that. Your family. So I want you to think about one common trait that you have with your parent and grandparent. If you don't know your parent or grandparent, talk about two different family members. And family is pretty arbitrary and it's vague, and it's how you want to define it. But think about something that's in common. Here's a time to breakout rooms. I'm going to skip that because it's not important for you. Here is another spot on your worksheet where you have to answer a question. Make two observations about the table above. You've got a table right here. I'm not going to reveal those observations because I'm going to continue on ahead, but you have to write this on your worksheet. You're going to answer the question: how are the chemical families grouped together? You're going to make two observations. There's not a spot on the worksheet for you to answer this. You have to make a spot. Make a spot, be like, the answer to this question is this. And I need to see it. Families on the periodic table. What is this family's name? It's boron. That's why there's boron right here. What direction does this family go? Don't worry about it. Don't answer these questions on your worksheet, by the way. I'll tell you when you need to. I'll be very explicit about when you need to answer these on the worksheet. Answer the question: what families does this go? They're vertical. They are vertical. So all of these different families, they are all vertically aligned. Okay, so where does this element belong? What family does it belong to? Okay, you might see like yellow, yellow, match the family. Okay, this is an element. Since it's one block right here, that means it's one element. It's part of the boron family. What about this pink one? Take a second to pause. Oh, that one's part of the oxygen family. Okay, let's think about these vertical families. Here are all my matriarchs lined up. My mom, my grandmom, great grandmom, great great, great 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 great. Cool. Look at that. We're all related down here. Oxygen family, that's all related. What I mean by related means that they have similar properties. So you might say like, oh, all of you women in this family have curly or wavy hair, and all of you are white. All of you have similar noses. Oxygen, sulfur, selenium, these don't have noses or hair or skin color, but they have different things like flammability and how dense are they? And do they conduct electricity well? Tons of questions we can ask about with chemistry. So this is an exercise where you're going to answer this on your worksheet. You're going to tell me two elements that you think are similar. Pause, and I want you to try that. So two elements that I'm going to give you as an example. Nitrogen and phosphorus, they are similar. Why do I say that? Because they're in the same vertical family. You could have said fluorine and chlorine. You could have said argon and krypton. Two elements now you think are not similar. Again, you need to answer this on your worksheet. Okay, any two elements that are not in the same family, think about it. This could be like, oh, this is Murray's family right here, the oxygen family. This is Chervin's family right here. They might be like somewhat similar, but they're different families. We can't say for sure whether or not two things are going to be related. I know that oxygen and sulfur are related, but I'm not certain if nitrogen and oxygen are related. So you could have said things that are not similar, like carbon, sulfur, not similar. Boron and krypton, not similar, because they're not in the same family. Okay, we're going back to our do now. How many electrons in the outer orbital? There's 4 electrons on this outside ring. We're always going to think about what's the farthest orbital from the nucleus that actually has electrons in it. Because I could draw all the orbitals that actually exist that are empty, but who cares about all those empty orbitals? I want to find out about the orbital that actually has stuff in it. I don't care about the innermost orbitals, and we're not necessarily going to get into why. We just know that the outermost orbital that actually contains electrons is the one that's important. That's why we care about the 4 here, not the 2 here. Why are they super important? Because they are valence electrons. This is a word that we're going to come to know and love, and you're going to have it be your little creed that you're going to answer every question back. It's the valence electrons. Cool. Here's a little prediction I want you to make on your worksheet. I want you to predict why valence electrons are important. This might be hard to come to, but you just make some predictions. What do you know about atomic models? We've spent a lot of time with atomic models at this point. You should know something about their position at least. Predict why you think they're important. What sort of consequences could they have? Okay, I'm going to show you 3 different slides here. Then you're going to pause and write down what's the pattern you think you notice. Got an H here and a dot, H here and a dot. Okay, Li, dot, dot, dot. Remember these dots are electrons. Ooh, Li, 1 dot here. Sodium, ooh, lots of electrons, lots of electrons. Ooh, okay, what about this? So what I'm saying here, folks, is for each of these, the outermost electron, ooh, this one has 1 outermost electron. Ooh, these are inner electrons. This one has 1 outermost electron. This one also has 1 outermost. All of these in this vertical column have 1 outermost electron. Reminder, valence electrons are the outermost electrons. So I told you they're super important. Interesting. I seem to have only talked about the only important electrons here. 1 valence electron, 1 valence electron. Here's an exercise that you're not going to do. If I want to add a valence electron to here, I can't add it to the black ring. The black ring is full. We're not going to get into why right now. We will get into that in the next unit. So it has to go in the green ring. Has to go in the green ring. Take a second to answer this on your worksheet. What do you think? What do you see? What do you think? What do you wonder? On your worksheet, pause, see, think, wonder. There's no correct answer to this, but I need to see what you're writing. Observations you might have made. Look at the number of valence electrons. They're increasing by 1 every single time. There's a maximum of 8 over here. There's a minimum of 1 over here. Ooh, there's not even the things labeled on the inside. It's not because the things on the inside don't have valence electrons. It's just because the pattern isn't very easy for the transition metal family. Okay, don't answer this. Don't answer this. Here today we played music by Octo Octa and Eris Drew. They're two trans women who are dope DJs. They're awesome. If you want to look up Eris Drew and Octo Octa B2B, that's like the letter B, the number two, letter B. You can play their Sugar Mountain Rush uh, B2B. That's like a thing they played in Australia. It was really dope. Good music, good vibes. Okay, important notes to take now. I'm not going to go through these and read these because you can pause at your will to get these. So here's a second to pause for this. 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 All of those absolutely need to go into right here, these definitions. Reminder, this is the last time I'm grading this learning goal, so you probably want to do it. Now there's going to be a time for you to create your own definition. So below where you wrote in my definitions, you now need to write in your definitions. This is not going to be reassessed next class. This is the last time I'm assessing this. This should be free points for you. All you got to do is do it. Here's the important thing on notes on valence electrons. Notice the transition metal family. No pattern here. These have valence electrons, but they sort of alternate between like 1, 2, and 3. They kind of have a mixture. So there's no clear pattern. But these families, all of these families have a set number of valence electrons, and they increment by 1 every time you go across. Practice questions. Pause on each of these, read them to yourself, come up with an answer. Correct answer here is C. Pause for this. Correct answer here is B. How many valence electrons does this have? Pause. Correct answer is A. So I'm going to pause here. Correct answer here is B. And I'll review for these two. Why is lithium? Why is the answer 1? There's 3 total electrons, but valence. Valence means outermost. Look, 1 right here. This is the outermost ring. Why it's 1. Here, the outermost ring is the green one because it has electrons in it. It's got 2 of them. Answer for this one. Pause. Okay, cool. This is B. It's got 4 valence electrons. Okay, which 2 elements do you expect to both be flammable? You can take a second to pause, but I want you to think about this word here, both. So you might not know what flammable means, but flammable means like how easy can it catch on fire? And the key word here is both, because if I know that one of them is true, the other one's got to be true if they're in the same family. O and F, are they in the same family? Nope, 2 different families. C and O, C's right here, O's right here. Ooh, not the same family. O and S. Okay, so if oxygen is flammable, that means sulfur must be flammable too. Let's apply that same sort of logic over here. Which 2 elements do you expect to both be excellent conductors of electricity? A note here that all of these conduct electricity, but some are excellent conductors of electricity. Okay, applying the same thinking here, which 2 are in the same family? We see here that C, Ag, and Au, silver and gold, are the only ones that are in the same family. So the answer was C before. Which elements do you expect to be gray? So both to be means pretty much, oh, are they in the same family? And we see here that zinc and mercury, Zn and Hg, are the only ones in the same family. You can double check me. The other ones are not in the same family. Like copper and zinc, copper, zinc, they're next to each other, not in the same family. Okay, you're going to take a second to answer. There is a spot for you to answer this in your notes, so you don't need to like create a spot. But we're going to talk about 2 things that you learned doing those practice questions. Here's the exit ticket. Neon and xenon gases emit photons when they are connected to electricity. Oxygen gas does not emit photons when connected to electricity. This is a new phenomena. You didn't know that before, or maybe you did, but if not, you certainly know that this is true right now. I'm going to come with an explanation right here. Neon and xenon are in the same chemical family as oxygen. Neon and xenon have 8 valence electrons, while oxygen has 2. This is why we see the gases behave similarly. So I got a spot for you on your worksheet to do this. So reminder that everything above here got to be filled out. And I'm grading everything on this worksheet too. Exit ticket. You've got the same thing that I just said right there, but now you've got this part right here. Make corrections to my explanation. I have 3 errors in the explanation. You've got this periodic table here that's got the dots that are pretty helpful. You got to remember what they represent. And now you can create your explanation down below. I will be grading that. I think that's it. Yeah, so this sheet right here is worth 2 learning goals. The exit ticket is 1 learning goal, all of the other stuff is note taking, and a reminder that there should be, like, a lot of stuff, below here and above the definitions where I'm, like, highlighting. In between these 2 places, you should have been answering, like, all of these questions that I was asking. When I said, "Do this on your worksheet," go back into the video and watch it again. Be like, "Did Murray say do this on the worksheet?" Then I need to see it on the worksheet. Didn't create a bunch of spaces for it because I didn't plan ahead like that. Sorry. Uh, hey, I'm not perfect. I'm just Murray. Speaking of which, I'm going to give a little stop share and give you a little hi, goodbye. Enjoy your Friday if you're watching this on Friday. If not, I don't know when you're watching it. Enjoy whatever day of the week it is. Sure, it's good. Later, friends.